which is sine of alpha plus beta equals sine alpha multiplied by cosine beta plus cosine alpha multiplied by sine beta. So first what you want to do is draw a 180-degree line and label that, well, not line but ray, and then label it AB. You want to have one point labeled B that's on the ray, and then your endpoint, your one endpoint, will be A. So here we have our line, this point, like I said, A, and here we can put B. Next, you want to make a rotation, and then that'll create angle CAB, another ray, rotate and add a ray, and then somewhere on that ray as well, add a point, label it C. There's another ray. Then we can label it C, like right about here. Next, you want to let the measure of angle CAB, let that equal alpha. Next, you want to make another rotation, another ray, rotate a bit more than the last one, and then draw another ray. It doesn't have to be as long. You can make it as long as the last one if you want, but it doesn't really need to. And then you want to label a point near the end with D, and that'll create an angle DAB. So point right here. No, I'll make it move up. Just because. So point close to the end of the ray you drew, and then label that point D. Now you have angle DAB. You want the measure of angle DAC to be beta. So, like that. Next, you want to draw a perpendicular line from D to AB and label that new point you make E, so that'll make DE. And since this is a perpendicular line, you just created two right angles. There's one. The other one is over here. But if you already have one, you don't really need to label the other one. Okay, now you should notice that the sine of alpha plus beta is DE over AD, because sine is opposite over hypotenuse, and the opposite of this angle right here, which is alpha plus beta, opposite is DE, and the hypotenuse is AD because of this perpendicular line. It makes the right angle, and then the hypotenuse is the side that is opposite of the largest angle, and the largest angle here is the right angle. Next, you want to draw a perpendicular line from the point D to AC, and then label that intersection point as F. So you're creating line DF. This is a right angle as well, because it's perpendicular. And then don't forget to label this as F. So next, you want to draw another perpendicular line from F to AB, and then label that point of intersection with G. And then let me move to F. That would be a good idea. So, perpendicular line from F to AB. Make this point G, and then we have another right angle right there. So then you want to draw another perpendicular line from FH, well, just from F to DE, and then that'll create line FH, because you want to label the next point as H. There we go. This is H right here. You have another right angle right there. And you also have one right here. So, and now you want to be able to notice that HF is parallel to AB, which indeed it is. And then you also want to notice that the line, or the ray, or you could say segment if you're stopping at C, but AC is transversal to HF and AB. AC transversal to HF and AB. It does cross both of them. And this means that the angle HFA, that's right here, is congruent to CAB, which is right here, because of alternate interior angles, sorry. And then you should be able to notice that angle HFD, which is this one, is complementary to both angle HFA, this one right here, and angle HDF, which is this one right here. Complementary, meaning it'll equal 90 degrees. Which therefore means angle HFA, this one, is congruent to HDF, this one. So let's go ahead and mark that. We figured out that HFA is congruent to CAB, so give it a mark, one little line, one curve. And then we also found out that HFA is congruent to HDF, so let's also give it the same line. So this means that the measure of angle HDF is alpha as well, because if it's congruent to HFA and HFA is congruent to CAB, that means all three of these equal alpha. Now remember that the sine sum identity is, we said it was, remember how I said that the sine of alpha and beta is DE over AD? DE, AD. Then you should be able to notice that DE, this line, equals HD plus FG, which is true, because, yeah, I don't really know how to explain that one, but you can see it. So from there you can show that the sine of alpha plus beta equals DH plus FG over AD. which is true, because these two, when you put them together, it'll be the same as dE. So then, if I could write that down for you. dH plus FG over AD equals sine of alpha plus beta. So then you can split the fraction to look at this in a different way. So let's go ahead and do that. FD, no, wrong way. dH over AD plus FG over AD. And then you can multiply both of these by a form of 1. So we can multiply this by FD over FD, and this one by AF over AF. So let's go ahead and do that. I'll just write it again, just to make it look better. So there you just multiplied both sides by a form of 1. And then now you can go ahead and rewrite it as this. So what this is saying is sine, this is equivalent to the sine of alpha, and this is equivalent to the cosine of beta. This is equivalent to the cosine of alpha, and this is equivalent to the sine of beta. So let's go ahead and look at this. I said this was sine of alpha, cosine beta, cosine alpha, sine beta. So sine of alpha, opposite over hypotenuse, FG over AF. That's true. This is cosine of beta. Cosine is adjacent over hypotenuse. This is AF over AD. That is true. Cosine of alpha, DH, let's see, DH, which is the same as FG, over adjacent over hypotenuse. Cosine of alpha, yeah, adjacent over hypotenuse, okay. FD is, oh, we just used this triangle, that's why. So when you look at this angle, the adjacent would be this side, DH, yeah, adjacent, and then hypotenuse is FD right there. And then the sine of beta, FD over AD. AD is right here. Yeah. So that's really it. So I can just rewrite this. This is just saying this, but the final equation from the construction will end up looking like that. Well, I just wrote too big. And that is the construction proof of the sine sum identity.